Hello, Calculus 2. This is Dr. Johnson talking to you about the Python version of numerical integration. So this is in Google Colab. So you can get it to it from colab.research.google.com. And I've changed things around from when I last shared it with you. So remember, you should be able to get this like open in Drive, and you should be able to find this file, and you should make a copy for your own sake, because I think I made it so you can only view it. You can't edit this. So if we're doing this in Python, Python is not made for mathematics specifically like Sage is. So we need to add some packages. So we're going to import NumPy, which is a package meant for doing stuff with numbers. So that will give us things like cosine, sine, log, e to the x, functions like that. And then we're going to use SciPy for its scientific computing, which will give us a good, really good numerical integration method for double checking. So now what I did was I imported NumPy as NP, and then I only imported one little module from the SciPy, just the integrate module. So since Python's not built for math, it doesn't know that when I think about E, I think about 2.71828. So I need to define it. E equals NP dot E. So NP is the NumPy. And so then when you do like dot, so I just kind of like we're typing here, E equals NP dot. And then NP has all the, if I do dot, then I can look at all the things that NP has. And one of them, there's so many things. And so one of them is E, which is a float. Okay. Also, this is a function, or I think. So, ruin that. Then there's, we can define functions. And again, because Python is built for like everything, not specifically for math, it's going to look a little weird. And I'm not the best at Python, so I might not be doing this the very best way, but it is a way that works. So we're going to find a function, f, and then we're going to use lambda notation. So f equals, and then lambda x, this is saying I'm going to use the variable x, and then colon, that's important, and then your function. So in this case, this is going to be natural log of x divided by x plus 3. So natural log is a function that Python doesn't know. So I do np.log, and so np.log, and that's the natural log function. And then I'm gonna, so then divided by x plus 3, and then the normal like addition and division are the normal symbols. So then there's a couple other functions, and you can make this one disappear by adding a hashtag, and then it's a comment, so Python won't read it. And you could change it to like e to the negative x squared instead. So I'm going to do it for this function because it's one of the functions from question 7 for me. So question 7 has log of x divided by x plus 3 from 1 to 10 with 12 intervals. So then if I hold down shift and press enter and keep pressing enter, then that's the actual answer. And I keep going. There's the midpoint. And there's the that's the error. There's the trapezoid. And there is Simpsons. So notice I've got midpoint is 1.6015 and midpoint is 1.6015. And trapezoid was 1.584 rounds to 1. And trapezoid is 1.5841. And Simpson's rule is 1.594 rounds to 9. So 1.5949, 1.5949. So I got all the right answers to that question. Okay. Now, when you get questions like number 6, where you have all these, you can do it by hand, There's another way to do it if you feel like using Python, but this way breaks easy, so be careful. So what you need to do is you need 2 lines. So first you need your table and then a function defined from that table. So the table has x value and then colon and then y value. Okay, and then x value colon y value, x value colon y value, comma. And so all these things, the commas, the colons, the curly brackets, they're all important. If any of them are out of place, it will break. And all these numbers would have to be exactly the same as this table for me. So I have 16, negative 16 goes to negative 9, negative 15 goes to 7. So in my table, I have negative 16 goes to negative 9, negative 15 goes to 7, so on and so forth. So then you'd have this line to make a function out of that table. And then you would need to have, so make sure these are all exact. So negative 16 to what? Negative 10. And that makes 6 intervals. So if I do that, then I need to not run this next one because my function is only defined on like a couple points. There's nothing for to numerically integrate. And I can't do the midpoint rule if because there's no midpoints. There's only these points. I can only do trapezoid rule and Simpson's rule. So in this case, the question is asking for Simpson's rule. So let's just jump down to Simpson's rule. Run that, negative 5.3 repeating. And that is the right answer, negative 5.3 repeating. So hopefully this helps. I'll also put the Sage version on there if you prefer to like download Sage and use the Sage, because with Sage, things make a little bit more sense. So the Sage version is just a little bit easier to read from a human perspective, like natural log is natural log, and then f dot integral and things like that. And so if you wanted to change your function to be like cosine and sine, Sage already knows what those are. You don't have to import any packages. But the problem with Sage is it's hard to like figure out like downloading, installing, and then how to load a file. You have to know a little bit about like where your files are and stuff like that. So the Colab might be the way to go for this homework. So that is it. Have a nice day.